using the Hinge theorem. All right, so first we're going to need to figure out what is the Hinge theorem. So the question says compare the given measures by choosing less than, greater than, or equal to. If there is not enough information, select cannot be determined. If necessary, you may learn what the markings on a figure indicate. So if you don't know at this point, you should know what the markings are. So slashes, which I call tick marks when I'm talking in my videos. So if you have 1 to 1, that means that those sides are congruent. 2 to 2, those sides are congruent. So the number of tick marks, or slashes as they're saying, indicate which sides match or which sides are congruent. Same thing with arcs. So 1 arc to 1 arc means that these angles are congruent. 2 arcs to 2 arcs mean that B is congruent to C. Arrows. So these actually indicate parallel. So this 1 arrow to 1 arrow indicates that the left is parallel to the right side. And then 2 arrows to 2 arrows indicate that the top here is parallel to the bottom. So that's just kind of a quick reference for parallels. And then square. So if you see a little square in the corner, what that tells you is it's a right angle, and right angles are equal to 90 degrees. So if you see the right angle mark, then you know for sure that it's 90-degree angle there. So that's just a really quick reference to the figure markings. And then we need to go down here and we need to read about the Hinge theorem. So the Hinge theorem, suppose 2 sides of one triangle are congruent to 2 sides of another triangle. So I have 2 different triangles, 2 sides of, and we can even look at this one here. 2 sides of the red triangle are congruent to 2 sides of the blue triangle, and I'm just using the red and the blue because of the angle here. So we have a mark here, 1 to 1, 2 to 2. So we have 2 sides here, 2 sides here. And the included angles are not congruent. So this area in red is not congruent to this area in blue. So we have, and I'm hoping we can see that pretty easily. The red one, angle A, is quite a bit bigger than angle X, the blue one. So if we have this situation, then the longer side is opposite the larger included angle. So if A is larger, then we go here and BC needs to be greater than XY, which is across from X. Sorry, YZ. Jeez Louise. I said XY. Not thinking about it because just being silly right now. So across from X is YZ. So this red line needs to be longer than this blue line. And that's the Hinge theorem. And if you think about it, if I have, like my hands, can go, don't want my pencil to roll away. So I have my hands, and here's a small angle, and I want to measure the distance between my fingers. Well, if I make the angle bigger, the distance grows. If I make the angle smaller, the distance shrinks. So that makes sense, the Hinge theorem. As far as the farther apart the sides are, the longer that line between the tips of my fingers will be. And if my palms are getting closer, then the shorter the distance between my fingertips. So that's just the idea of the Hinge theorem. And the opposite is also true. So if suppose the 2 sides of a triangle are congruent to 2 sides of another triangle, and the third sides are not congruent. So now we're talking about the third side. So now we're talking about BC, the red line, and YZ, the blue line. So now if we have that situation, we don't know the angles, but we know the sides. So we still have congruent to congruent, congruent to congruent, but the third sides are not congruent. So then the larger included angle is opposite the larger side. So we went from sorry, I wanted to make sure I wasn't saying it backwards there. So if we know that, then we can go back and forth with it. So it goes forwards and backwards. So if we know BC is larger, then angle A has to be larger than the angle opposite this one, which would be X. So it's just one of those quick references that we can go back and forth. So if you're given the angle, then you can go to the side. If you're given the side, you can go back to the angle. So, and we call that converse, which kind of just means opposite or backwards is the way I describe it in class. All right, additional fact. Suppose that two sides of one triangle are congruent to two sides of another triangle, and the included angles are congruent. Then the third sides are congruent. So if the angles are congruent, and again, go back to my hands. So what we're saying is if we had two angles and they looked exactly the same like this, and the angles are the same, so this angle in here is the same, well, then the distance between my fingertips would be the same. If I had two pairs of hands, then I could have, this angle here, and then I would have another angle here. So I could have two different angles that were the same. So it's just saying that if that included angle is the same, then the distance is the same. If you have two sides congruent to one triangle and two sides congruent to another triangle, and the distance between, say, my fingertips is the same, then the angles will be the same. So this is just using that same idea, but now we're talking about the third side or that included angle being congruent. So then they want us to go through and apply this information. And the only thing I don't know, do they tell us about included sides or shared sides? I don't think, it doesn't look like they talk about it too much right there. So they do have to get into a little bit. Now, this BD, the way this triangle is drawn, this is shared between the two triangles, which means it's congruent. BD is congruent to itself. We call that reflex. So I can see AB is congruent to CB. I can see that with these little congruent marks. And then I also know BD is congruent to itself. So I have two sides from the left triangle are congruent to two triangles from the right triangle. So left triangle, right triangle. And then we want to say, what is the relationship between AD and CD? So AD is this one here, and CD is this one out here. Okay, I didn't necessarily mean to draw that line, but I'll get rid of it just so it's not bugging us, or bugging me more accurately, because I didn't mean to hit the pad on that one. So we just have to decide what's the relationship. Is it less than, greater than, or equal to? Well, 41 is not the same as 22, so it's not going to be equal to. But remember, the side opposite the bigger angle will be greater. So AD is going to be greater than CD. So then we select in here greater than, just like that. All right, I'm going to clear that out. The next one here, so we have a side and a side, congruent, and then we have a side and a side. So I have one tick mark to one tick mark, 2 to 2. And then they give you this third side here. So I have 9 and 7, and they want us to decide something about angle F and angle Y. So remember, I can go from angle to side or side to angle. I can go back and forth. So if I have side, the greater side is going to be across from the greater angle. So 9 is greater than 7. So Y has to be greater than F. So I would just choose the one that we're, think of it like the alligator, or I really like doing Pac-Man here. So Pac-Man's hungry. He wants to eat the bigger number. Okay. All right, we have one more to look at, and then we'll actually get started here. So with this one, we're given 15. So I'm going to mark this one. We're given 15 and 15. So we don't have tick marks, but we know 15 matches 15. And then we're given 8 and 8. So we have two sides from the left triangle congruent to two sides of the right triangle. So now they want us to make a decision about KL and QR. So they want us to make a decision about these ones. So remember, we can go opposite the angles. So 92 is bigger than 61. So that means that KL is going to be bigger than QR. So then I do my little, Pac-Man guy, and that's eating KL. Okay. So let's go ahead and clear this out, and whoops, help if I hit the cursor. All right. So let's go ahead and get started on this one. So we are going to start marking. So I have 8 and 8. And then I have 14 and 14. 5 and 13 don't match. So we're not going to have an equal situation here. We need to make a decision about T and Z. So we need to go opposite the greater number. So 13 is greater than 5. So T is greater than Z. T is greater than Z. All right. Let's go down here to the next one. So we'll go back kind of to our blue here. So we need to make a decision about angle Q and S. So we know we're going to have some sides. So I have 10. Forgot to hit the pencil. I have 10 and 10. And let's go to blue. I have 21 and 21. So they don't give me any other angle marks, and it doesn't look like they give me any other lengths. But what they do give me is a shared side. And I know PR is congruent to itself. So PR is congruent to PR. So they're giving me all 3 sides are congruent. So then if I'm looking at, let's do this in a pink here, Q and S. Well, if the third side is congruent, then they have to be the same. They have to equal each other. So remember, think of the Hinge theorem again. If I have the same 2 sides, then the length between my fingers will be the same. So we want, gotta switch this over to, and so I'm going to put equals. All right, last one here. So I'll just start off with pink. So we want to make a decision about KJ and KL, so the sides. So if I'm making a decision about the sides, then I must have an angle, which I do. So I can see one mark to one mark, right? Which, instead of covering up all the other stuff here, change my mind on that one. I'll just do the tick marks here. So one mark to one mark. So I have one side, I have an angle. Doesn't look like they gave me any other information, but I do have shared side. So remember, if I have a shared side, Km is equal to itself. So I actually have 2 sides from the left triangle are congruent to 2 sides from the right triangle. So now if I want to make a decision about KJ and KL, I just need to look at the angles. So which one's bigger? 109 is definitely bigger. So KJ must be bigger. So we want our little Pac-Man guy, and I know I don't get to draw it on this one. It's not quite as fun, but still, we want it to be going in that direction. All right, so let's clear this out. So I don't think I'm going to draw quite as much in the next ones. I just wanted to draw that one out so you could see everything. So this one I'm going to go a little bit quicker. So this one I have 1 to 1, and then 2 to 2, and then I have the same exact angle. So remember, if it's the same exact angle, neither one is bigger, which means that neither side is bigger either. It means the sides are actually the same. So we would say they are equal to each other. All right, down here, so let's go back to the pencil. So we have 4, 4. I have 6 and 5, so I can't mark those, but I have a shared side here. I know EG is congruent to itself. And then I want to make a decision about DEG, so I'll put this in red. DEG, so I just followed DEG. That came off a little bit more orange. Grabbed it a little too quick. And then FGE, so this angle here. So remember, if I have the sides, I just go, which side's bigger, 6 or 5? 6 is bigger, so I'm going to go to this angle. DEG must be bigger than FGE. I'm going to choose greater than. All right, next one. So we have 1 to 1, 2 to 2, and we need to make a decision about PR and XY. So then we look at the angle, which one's bigger? 93 is bigger, so XY must be bigger. So I pick less than and check. And we got it. All right, next one, clear. Okay. So we have 16, whoops, gotta click my pencil. 16 to 16. And again, they give us the angle. It doesn't look like they give us anything else, but we have a shared side. So now we need to make a decision about WX and WZ. So I'm going to go to the angle. I have 93, I have 76. 93 is bigger. So WX must be bigger. Okay, pencil. So now I have 1 to 1, 2 to 2. And I don't have any angle marks, but I do have these two sides. They don't match. So I need to make a decision about T and E. So T and E. So which one's bigger? 16 is bigger than 10. So E must be bigger than T. So E is bigger than T. And so this says T is less than E, but it's still eating the E, going that direction. So that's how we know it's bigger. All right. So now I have 6 to 6. So 8 and 9 don't match, but they share a side. And we need to make a decision about ABD, so this angle, and CBD, which is this angle. We need to make a decision about these two angles. So I'm going to look at the sides, 9 and 8. 9's bigger, so CBD must be bigger. So I have this one, and I'm going to click check. And we got it. All right, we finished another one. Let's clear that. Next.